Wabarakatuh. My name is Muhammad Syahid Ilyas, and my number is the E20127. So I'm going to explain on the project background for introduction in the analysis of electric field between electrodes. From this experiment, this design and the analysis of electric and magnetic field play a vital role in numerous engineering application. This project aims to explain the analysis aspect of electric field distribution between electrodes and the magnetic field behavior within a device. FEM, or also which known as finite element method (FEM), will be employed as a numerical technique to model and simulate this field accurately. So following on to the objectives are as follow: to simulate the values of maximum electric field Emax for each gap distance, to compare between the manual calculation and the simulation results, and lastly to develop understanding on the concept of electric field in electrostatic problem using FEA analysis. And for 1.3, the scope of experiment, to analyze using the use of finite element method magnetic in the experiment, to study the air breakdown data for different gap distance of voltages with having a constant sphere gap of radius 25 cm, to explore the behavior of varying electrode spacing on the electric field distribution. And last one for the introduction part is the literature review. Studies have examined the distribution of electric field between electrodes. The research emphasizes the importance of accurately quantifying the electric field distribution for understanding its behavior and potential application. The analysis revealed that smaller electrode spacing led to a more concentrated electric field between the electrodes, which enhanced the validation efficiency of particulate matter. Understanding the relationship between electrode spacing and electric field distribution is crucial for optimizing the performance of electrostatic devices. So that's all for introduction. Following on to the next methodology part, this flowchart will explain the procedure for conducting the experiment task 1. So starting from we are going to start, and then for going for the software selection of finite element method, and then to creating the 3D model of the experiment, which is assigned in the lab sheet experiment, assigning the material properties and model geometry. Afterwards, we conduct the simulation using the FEM software, and after the simulation is done, we analyze the result from the simulation that we have been gathered. And if it is not accurate, we are going to make adjustment before having a finalized result, and then we record the data observation and work on completing the task for the experiment. And for question number 1, the calculation of error of the maximum electric field Emax between simulation and calculation for every gap distance. As we can see here in the table, for every gap distance of 1 cm until 17.5 cm with different voltages, the maximum calculation between simulation and calculation for Emax value, the error, each has been specified in the table below. So from 0.292 until 0.045. So that's all for the simulation. And that's on to the using the Emax value from simulation, calculate the field utilization factor for all gap lengths using this formula. So from the previous simulation value that we have gotten, now we just let into the calculation part of average electric field average calculation with the formula given, and then we apply both of the value that we have gotten into calculating the field utilization factor, and we get from gap distance of 1 cm, which have a 0.98 field utilization factor, and until the gap distance of 17.5 cm with the final utilization factor field of 0.80. So let's conclude my report. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syahira Binti Ahmad Safawi. My matrix number is BE20093. So this slide is going to demonstrate on how we get our result for simulation using FEM software for task 1, which is the analysis of electric field between electrodes. So basically, for this task, we use air and copper, which is the relative permittivity is 1 for air and also 1 for copper. For the this is the gap distance, which is for gap distance that has been stated in our lab report, which is 1, 1.5, 2, 2.53 until 17.5. So this is the gap distance. So we can change the boundary. So for this, the boundary H1 until H13, which is the gap distance 1 until 17.5, and for copper on the upside is the ground. We set to the ground, and for this we set to the gap distance. For this, I show for the for gap distance for 10 cm. So after we have done for the draw, we mesh. So this is the value of the Emax value. We need to set to the field intensity. And then This is the gap. Also set to the magnitude of the field density. So this is the graph that have been get. So here is the we show the simulation for gap distance for 1 cm, 3 cm, 7.5 cm, and lastly for 70.5 cm. So this is the image value that we get from our simulation. And that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. For task 2, which is the analysis of force of a gap CI core. The background of the study: the magnetic field is the area where magnetism's force operates on a magnetic substance for all a moving electric charge. A gap CI core is a magnetic core that is commonly used in transformers and inductors. It is made up of a C-shaped iron core with a gap in the magnetic path. They are capable of lifting and moving iron blocks and other magnetic materials because they are simple to use and safe to handle. They are commonly employed as lifting device in factories, ports, warehouse, and transportation industries. For example, electric motors use the electromagnetic force between a magnet and a current carrying coil to produce movement. For objective, understand the concept of electrical field in electrostatic problems. Second, able to create the model for finite element analysis by considering material properties, boundary condition, and mass generation. Third, able to open boundary condition of an unbounded problem. Lastly, able to understand the concept of leakage flux, mutual flux, fringe effect, and the force exerted in electromagnetic system. For metrology, method used to model the system using the software is FEMM, which is the finite element magnetic, which is the well-known program that may be used to address a variety of electrostatic and magnetic issues. The FEMM was utilized to derive the solution in this section. First, the materials of the model are applied. A dialog will pop up with edit box for the various material properties. Each material and parameter region will be defined based on the task demands and requirements. After all the requirements have been assigned, the file is saved and run using the mass generators. The part of the parameter can be viewed in the post-processing windows by clicking on the density plot tool. For that reason, FEMM may be a suitable option for analyzing the force of a gap CI core. So this is the flowchart of the task 2, which is first start with the literature review, then creating a model using FEMM software, then run the simulation, analyze the flux density, field intensity, and current density, simulate the result and analyze using graphical method, and lastly discussion on the result obtained.
Yeah, Assalamualaikum. My name is Muhammad Zaid Muhammad Fazlan and my number is 819070. And today I'm going to explain about the task 2, which is the analysis of force agreed on CI core. So for the value exerted force right here is for the X component is equal to negative 145.087 N, and while for Y component is negative 0.0159492 N. So for the first one, we need to do right here. With the same parameter given as in the left sheet here. Because the intensity have with the 10 AWG cable with 500 turn and 50 N, and also the M50 still. Okay, next we are going to run this right here. Mesh it. You can see right here the result from the match. So as you can see the FEMM output right here, and as we are going to go for the flux density. So just flood and show the density part right here. Yes. Then if you can see right here, okay. So for the flux density, the simulation show the highest recorded value for the flux density is equal to 9.95 as per Tesla. And next we are going to find for the field intensity. This is a result simulation for field intensity. While for the current density, as you can see right here, show the current density at the coil right here, and with the FEMM output. So that's all for me. Thank you.
Right, for the conclusion, the magnetic field is the area where magnetism force operates on a magnetic substance or moving electric charge. We may be deduced from this experiment that the narrower the A gap, the higher the flux density. This is because the closer the C and I cores are in the previous architecture, the tighter link in the more difficult their link, and the more difficult it is for charge losses to occur. Aside from that, the number of coils has an influence on the flux density. This is owing to the fact that the greater the number of coils around the electromagnetic, the greater the flux density due to the magnetic induction.